Alright, so for this problem we're asked to find the local maximum and minimum of this function, h of y. H of y is equal to y minus 2 cubed minus y plus 1 times y plus 16. So the first thing we're going to do is split this up so that we can find its derivative. This is going to be equal to y minus 2 times y squared minus 4y plus 4 minus y squared plus 17y plus 16. This is just going to make it easier for us to solve it. Now we've got over here on this side y cubed minus 4y squared plus 4y minus 2y squared plus 8y minus 8, and all I did was just distribute the y and then negative 2 to these terms, and then still y squared plus 17y plus 16. Now I bring it all together, and we get y cubed minus 7y squared minus 5y minus 24. Alright, now we're ready to find the derivative of this, which is going to be h prime of y is equal to 3y squared minus 14y minus 5. Okay, now at this point we remember that we're trying to find the local maximum, and the local minimum. To do that, we're going to use the second derivative test. The first part of the second derivative test is finding where this derivative is equal to 0. So we want to find where h prime of y is equal to 0. To do that, we're going to factor h prime of y. When we factor this, we get 3y plus 1 times y minus 5, and again, if you distribute these terms, this is what you'll get. So I'm just rewriting it so that we can find the zeros for this. So the two y values that are going to give us 0 are, I'll put it right here, y equals negative 1/3 and y equals 5. Alright, so now what we want to do is find h double prime of y. So h double prime of y is equal to 6y minus 14. Alright, the next thing we're going to do is plug in each of these y values to find out if they're either a local maximum or local minimum, because we know they're one or the other. Because the second derivative is 0, we know they're going to be looking something like that or that. Like negative 1/3 and 5 are going to be somewhere that looks kind of like this on this graph of h of y. So now we just got to figure out which one of these it is to find out if it's a local maximum like this or a local minimum. Alright, so we're going to plug in h double prime of negative 1/3. It's going to give us 6 times negative 1/3 minus 14, which is equal to negative 2 minus 14 equals negative 16. Okay, so this tells us that the second derivative at negative 1/3 is negative. That means it is concave down, which looks like this. So it's going to be a local maximum. Again, remember that just because this is negative does not mean it's a minimum. Negative means it's concave down, and where the derivative is 0, the concave down, it's going to be a local maximum. So now we're going to plug in h double prime of 5, and we get 30 minus 14, which is equal to 16. So this is a positive second derivative, which means concave up. So it's going to look like this. This is concave up, and it's going to be a local minimum. Alright, now that we have both our local maximum and our local minimum, well, we have our y values for each of these, and that's part of the problem. The next part of the problem, it actually asks you to find what are the local maximum minimum, not just where are they. So this is our horizontal axis. Remember, this is h of y. So our graph is going to be something like that. Our y-axis is actually running horizontally. So we have, like, let's say this is a -1/3 and this is 5. But we want to find, okay, well, what is this value right here? What is the h at each one? So that's what we're going to do. To do that, it's really simple. We just plug in our y values back into this original equation up here. So we take h of -1/3 equals -1/3 minus 2 cubed minus -1/3 plus 1 times -1/3 plus 16. And you'll probably need a calculator to do that. The answer for that one is -23.148. So we know that, so our local maximum is equal to -23.148, and it is at y equals -1/3. Next, we're going to find h of 5. So that's going to be 5 minus 2 cubed minus 5 plus 1 times 5 plus 16. And that's going to be equal to -99. So our local minimum is -99, and it is at y equals 5. So notice that -23 is greater than -99, which is good. We did this right. So and so there's all your answers.